APIs. In this case, the STS sort of plays a role of sort of centralizing where you would validate or create the signatures over these REST messages that are being passed over HTTP. The signatures themselves are sort of communicated through HTTP authorization headers. So that's where you would go look to find the signatures that will be on these messages. Three-legged OAuth gets a little bit more complicated, and I'm not going to jump into all of the details here. There's all sorts of documentation online to go to look at it. But really, this is where you get the user involved. This is where the browser redirect dance happens. This is where user consent occurs, so the user sort of consents to the release of information on his behalf as you expose an API. There's a lot of value in what's being done here, even though it was sort of originally designed to address, how you might share Flickr photos online in a Web 2.0 context. We're seeing a lot of both enterprises and SaaS providers seeing value in taking this standard and leveraging it for other uses. I'd go so far to say that I've talked to some financial organizations that are looking to use this to expose account data online effectively so that people can get access to that information. And I've got another example of a use case towards the end here as well. So this is getting a lot of traction right now. I'm sort of surprised, but sort of not surprised, given there's been a wait for something to help address some of the use cases that three-legged OAuth addresses. All right, so real quickly, because I ran out of time. Sorry, Brett. So portal-initiated case web services are fairly obvious. We're seeing a lot of traction in the sort of service providers for SaaS and for cloud computing. And then what I'll call here rich desktop clients or even rich internet applications. The iPhone application is an example, but things that might be written in .NET to run on a desktop or in Java or in Flex to run on desktops. They're also talking APIs, and there are needs there to provide single sign-on in those cases as well. So one example, one use case we've got, and this is less a cloud case, but it's interesting more because it's the government, and they are so PKI intensive. They are leveraging SAML tokens in web services messages, even though every single entity in this diagram is basically pre-establishing or authenticating between one another using certificates, using mutually authenticated SSL. So the browser's doing that with the web portal. The web portal's doing that with the web service provider. The web portal's doing that with the STS. Authentication is happening via PKI. What they were missing, though, was the ability to convey identity information that's shorter-lived than what you can include in a certificate. So it might be role and group values that can change over time or in less than 12 months. That could be role and group values related to people or role and group values related to applications. And they've looked to standardize on SAML tokens and the WS Security SAML token profile as the way to communicate that information that's shorter-lived in a trusted fashion. And that information is being used to make authorization decisions. Microsoft calls this claims-based processing, but that's okay. I'm not trying to fight the Microsoft PR bandwagon, so we can call this claim-based processing as well. But it's a real example of what these guys are trying to do, and they're using it outside the context of what you might think of SAML tokens being used for, which is actually authentication. So another example here, another customer of ours is a large electronics retailer who I'm sure you've all bought something from in the past. I'm just not allowed to talk about who they are. It's really interesting. They built SOAP APIs to get access to, to both inventory as well as, what customers have purchased over the last 10 years. They did that with SOAP APIs originally. They've started with mutually authenticated SSL as the way to do that. But what they're seeing is that, again, is not giving them the granularity they need. What they're moving towards is a sort of, again, a SAML token-based model for making authorization decisions based on those SOAP APIs. And they're leveraging an STS for issuing and validating those tokens. The wrinkle here is that this retailer wants to shift to the Web 2.0 world, and they actually want to allow completely third parties to build out shopping applications totally outside of their control. You know, they're jumping into the Web 2.0 world in a big way here, so that somebody independently here in the room could go build a shopping application on the iPhone and you know, go register with them and get their key, and then, you know, leverage their REST APIs that they've built out to, you know, build out a shopping application to allow you to purchase electronic goods with this retailer. Their REST APIs are effectively an abstraction interface on their SOAP APIs, funnily enough. So that's the way they've chosen to architect this. But now they're looking to bridge how you might do authentication into those REST APIs through OAuth, and then bridging that back or proxying that back to how they're protecting their SOAP APIs, which is actually through the SAML token profile of WS Security. So I think it was Paul Madsen before who was talking about how these protocols, you know, tend to move from one to another, and, you know, sometimes there's an impedance mismatch, things like that. So this is an example of how this is shifting, where both OAuth and WS Security are both being leveraged in a valuable way. And I ran out of time about 5 minutes ago, but real quickly, we recommend using SSL for confidentiality of APIs, be they SOAP or REST. It tends to be the simplest and easiest thing to do. Think about using SAML tokens to identity enable your SOAP services. Think about using an STS to help centralize how they're handled, how they're processed, how they're issued. And then consider OAuth to secure your REST APIs, because there actually is a lot of traction happening there. And go check out the new release of our product up the back if you're interested. You'll see some stuff related to that up there as well. That's it. Brett. Any questions? All right, we're going home. We're going drinking. Oh, there is a question. Sorry.
On slide 20,
Yes.
what prevents that partner from impersonating the user, misusing the user's privileges at the web service retailer site?
That's a trust relationship that the retailer has chosen to have with a limited set of partners.
Would you like to do better?
Sorry?
Would you like to do better and make that impersonation not so risky?
Definitely.
So my question is, there is another approach for identity-enabled web service called IDWSF. So what's your, opinion about the IDWSF? Especially, I'm curious, how do you handle account linking or identity federation in WS Trust?
So if Sampo hadn't been here, Sampo would have asked that question, and Sampo was from SimLabs, so he's asked me that question a lot of times. IDWSF is a framework developed in the Liberty Alliance to address identity-enabling web services. My stock answer has been now for the last probably 4 years is that we actually, as we talk to people about these technologies and their stuff, we tend to find that, you know, people really don't understand how they can use that specification and that protocol. The way I would simplify this is that IDWSF does for SOAP what OAuth does for REST, effectively, at a very simplistic level. Unfortunately, today I only had about 20 minutes to talk about this stuff, so you know, in regards to that, I don't have the time necessarily to dig into how IDWSF might apply for some of those use cases as well. Did I answer your question, Kenji? Thank
you.
No worries. Anything else? All right, so I'll be at the Thirsty Bear in a couple of hours if people want to go and you know, beat up on me and stuff like that. Brett, thank you. Congratulations on Kantara, by the way.
Oh, thank you. See
Yes.
you there. All right, so this